Hi, and welcome back to this Blender tutorial series on creating a motorbike rig. In the first part, we separated all of our objects out ready for rigging, and in this part, we're going to set up our ground sensor controls, as well as creating an axle that runs between the front and the back wheel to create that rotational arc that you saw like this when the ground sensors moved up and down. So let's jump in and we can add in our armature, single bone. And the first thing that you might notice if you are used to rigging in previous versions of Blender is the introduction of bone collections under the armature tab. This has replaced the old bone layers system, which in my opinion is a very welcome change. That old bone layers system, which had groups of 32 little grey squares, was a very old hangover from the user interface of previous versions of Blender from 2.79 and earlier. The new bone collection system brings it more in line with the collections that we see in the outliner. So we're going to set up these first. The first one is we're going to call controls, and this is going to have all of the bones where we have all of our main control widgets. The second one we're going to call mechanical, and this is going to have all of the bones that drive the main bone constraints of our rig. And finally, we're going to have deformation, and that is going to have all the main deformation bones that are going to control the actual movement of the bike. So let's start by creating the initial deformation bones. So we're going to go into edit mode. I'm going to rotate this bone around, and we're just going to move it up to roughly the kind of center of mass of the bike. We'll call this def body, and we're just going to make sure by pressing M and move it to the deformation layer to make sure that it's on the correct one. We can then put our cursor at the back wheel, and this is why I suggested that you have the origin point at the correct rotational point of your objects. Go back into object mode, rotate this one around, and we can do the same for the front wheel. And rotate this around, and we're just going to scale these by individual origins 0.5 to make it a bit smaller. Call this def wheel back, def wheel front. Let's parent a few of our objects onto the deformation bones so that we can start to get a bit of a visual feedback about what our rig is actually going to be doing. So there's a couple of ways that you can do this. You could select the objects from the in object mode, shift select the armature, control tab to go into pose mode, select the bone, and then control P to parent to bone. But there isn't actually a faster way of doing this. While we're still in pose mode, you can actually still select objects directly from the outliner. So if I just click the wheel back, I can just parent it to the bone and do the same thing for the wheel front. Just makes things a bit quicker. I'm actually going to take all of these and move them to its own collection. I'm going to call it bike rig, and it means that I can turn this one off just to free up our 3D viewport a little bit. Let's rename this as bike rig as well. So we've got our main deformation bones in. Let's set up our ground control widgets. So if we go to the controls layer, I'm just going to turn off the other two for the moment. Make sure we're in edit mode, add a new bone, rotate it around and scale it up by about 1.5. This is going to be our root bone. For our ground sensors, we actually want the position of our ground sensors to be at the rotational points of our wheels. So instead of, we could just add them back in, or what we could do is we could go back to our deformation layer, select these, duplicate them, and just move them to the control layer. I'm going to call this ground sensor back ground sensor front. And we're going to parent both of these ground sensors to the root bone. Let's set up our widgets. So we go into pose mode. Under the viewport display drop down here, under the bone tab, we've got the custom object field here. So let's type in ground sensor, and that's going to change to our ground sensor widget. We can do the same here. And let's change this one to our root. Now we need to position these ground sensors, and under the custom shape you can change the scale, the rotation and the translation of these. Well, let's make this exact. If I go back into edit mode, under the bone tab you can see that you've got the location data for X, Y and Z coordinates for both the head and the tail. So let's select the Z location, back into pose mode, and under here I'm just going to do negative and paste it in. Do the same for the back wheel, copy, negative, paste it in. So now we've got those set up. So the next thing that we want to do is to start setting up some of our mechanical bones. And to start with, we're just going to take all of our deformation bones, we're going to duplicate them, and we're going to move them to the mechanical layer. The reason that we're doing this is that the deformation bones, I want to have a bit of a separation between what is being deformed, or like the bones that are responsible for the deformation, and the bones that are going to be responsible for a lot of the bone constraints that we're going to add a little later on. So I'm just renaming these to mechanical, so MCH for mechanical. And under our deformation layer, let's turn this back on. Up the top left corner, you can see the name of the bone that's selected. So I want to make sure that I've got my deformation bone selected. And I'm just going to parent them to the mechanical bones. Just for the moment, we will be changing this later on and controlling the position and rotation of the deformation bones via bone constraints and a bit of different parenting. But just so that we can get some immediate visual feedback over what our rig is doing, let's parent these deformation bones to their respective mechanical bones. So go back into pose mode, turn off our deformations. So far we can move our mechanical bones and it's going to move our pieces. Our controls at the moment aren't doing anything because we haven't set them up yet. Let's go back to our mechanical layer. And the couple of bones that we now need to add is the axles and our axis. So there's a really easy way to do this. We're going to select both of our mechanical wheel bones. We're going to scale around the 3D cursor. We're going to duplicate them. We're going to scale Z0. We're going to move our axles right to the bottom. So this is going to be mechanical axle front and mechanical axle back. The only other bone that we need is our main axis, which is going from the front wheel all the way to the back wheel. So cursor selected, we'll add a new bone. Cursor selected, I'm going to select the tail here, selection to cursor. We can call this mechanical axis. We're going to take our axis and parent that to the back axle. We're going to parent the body to the axis. So when this rotates, our body's going to rotate. We're going to parent the back wheel to the back axle. And the front wheel to the axis. And then finally, we can parent the axles to the ground sensors so that our controls will work. And then the only other thing we need to do for this is to now set up the bone constraints. And all of this will actually then start to work. So let's put our controls on. I'm going to go back into pose mode. And we're going to first of all add a constraint to the back axle. So this one. And we're going to add a damped track constraint. There is a track 2 constraint here, but this is a legacy constraint, which basically means that was used in previous versions of Blender, and you can see here the tooltip says that it's prone to twisting artifacts. I'd imagine that at some point in the future this will just be removed from future builds of Blender, but anytime you're doing tracking, you want to use a damp track rather than the track 2. So we can do damp track, targets our bike rig, and our bone target is going to be the front axle in the -y. And what this is going to mean is that now if I move my ground sensor, suddenly it starts to work. Because what's happening here is that I'm moving my ground sensor, which is moving my mechanical axle, and that is always going to be looking at this bone. So if I grab this bone, it's also moving, which means that I can grab my front sensor and this is going to move. But we also want to keep our front sensor constrained so that we can't move it like this. So to do that, we're going to use a limit distance. And we're going to limit the distance to the ground sensor back. We're going to change this from inside to on surface. If I hover though over this, you'll see it says that there's basically constrained on the surface of a virtual sphere. So now I've set up our axles. We can also go into the bone tab and just lock the X and the Y and all the rotation. So these can only move up and down. So it goes up and down. This one goes up and down. And if I move my root bone, everything's going to move. Finally, the last thing that we can do is set up our shrink wrap constraints so that we can set up our ground detection. So let's add a ground for it to detect. Let's go into object mode, add a plane, scale this up a little bit, and I'm just going to subdivide this a bunch of times. And I'm just going to add a modifier, deform, displacement, add a new texture, switch to the textures tab, and I'm just going to add clouds, make this really small, really big, sorry, actually, make it, drop the depth down, and let's just decrease the strength slightly, let's maybe add a bit more resolution. There we go, that looks okay. So what we're going to do is we're going to add a shrink wrap constraint to our ground sensors. So shrink wrap, our target is going to be our plane. And now obviously because the actual location of our bone is in the center of our wheels, we need to offset that shrink constraint. So like we did for the positioning the bone shapes, let's copy the Z location and we're going to paste that in, and we'll do the same thing for the front. We're going to add a shrink wrap, our target is our plane, copy the location and paste it in. The only difference here that what we want to probably change is that on these we're just going to change this from nearest surface point to project and also tick project opposite so that it's going in the Z direction, but it's also going to project in the negative direction as well. Project opposite, and now if we move our root bone, however we move our root bone around, our bike is going to stick to the surface of our plane. And the final thing that we're going to add to wrap up this part is we're going to add some custom properties onto, we can add this wherever we want. We can add this on our object, on our armature, or we can add it into our object. And we're going to add some custom properties that are going to act as drivers for some of these constraints, so that it's going to give us a kind of like a control panel for our rig. So I'm going to add a new custom property. I'm going to change this from float to boolean, and I'm just going to call this, make sure my caps lock is off, ground sensors. I'm going to right click and I'm going to do copy as new driver. And on my shrink wrap modifier, or shrink wrap bone constraint I should say, under the influence, I'm going to right click and just do paste driver. And I can do the same thing for this one, paste driver. So now, if I untick this, it just turns it on or off. The reason that we maybe want to do this, not only is it going to give us a bit of, it gives us a control panel, but with the ground sensors like on, if I try and move this, I can't, because that shrink wrap is constantly working and fighting against my movements. If I turn it off, I can move this. And that, I think, wraps up part 2 of this tutorial series. So we've actually covered quite a lot of ground here. We've added in all of our the start of our control bones. We've set up our main deformation bones and our mechanical bones. And we've set up our axle so that using a couple of bone constraints, our ground sensors are working nicely. Join me in part 3, where we're going to be setting up our suspensions. I'll see you there.